51 is bringing back the good old days. So you remember F net equals M, A net equals like F1 plus F2 plus dot dot dot, any forces. Any forces that make up the net force. So we're going to be doing that with torques. Just add a torque, add an I, add an alpha, torque net equals I alpha. We're going to be doing I of a disk, so this is not the old stuff, but that will help us find I. Then we're going to be doing kinematics with rotational variables to find alpha. So we're bringing it all back. What this problem is dealing with is a disk where you have a force here, F1, going, well, not really, that way, going like perpendicular like near F1, and you have F2 over here-ish going perpendicular like that way. So they're competing against each other. F1 is trying to rotate with a torque into the page, and it's rotating this clockwise. F2 is rotating with the torque out of the page, counterclockwise. So we'll do torque net equals I alpha, which equals, so let's say into the page, or out of the page is positive, so that's F2. So we'll go torque 2, and then minus torque 1 for into the page is negative. Yeah. Let's start with I. So we need the I of a disk. We can do that down here. I of a disk is 1/2 mr squared. Pretty straightforward. And that's 1/2. The mass of the disk was given as 0.02, and the radius of the disk is also 0.02. So we square that, and that gives us 4 times 10 to the negative 6 kilograms meters squared. So that we're going to stick right here. 4 e to the negative 6. Now let's find alpha. We can use the kinematics equation, omega final equals omega initial plus alpha t. And we're given a bunch of this stuff already in the problem. If you read it, we're given the final angular velocity. It starts at rest, so the final is 250 radians per second. Starts at rest, and it takes 1.25 seconds to reach that speed, so times 1.25, and solve for alpha, and you get 200 radians per second squared. Stick that up into here, and that's going to be times force 2, which we don't know. That's actually what we're trying to find. Force 2 times radius 2. Let me just expand this with the variables so you know where everything's coming from. So this is force 2 radius 2 minus force 1 radius 1. Of course, the radius is the same for both, right? And that radius is 0.202 minus, and then they do give us F1. It's 0.1 times the radius, 0.02. And I don't need to do algebra for you guys. Solve for F2, and you should get 0.14 newtons. Why am I speaking in strange accents that sound like nothing? And that's it. Not too bad, but a lot of cool refresher concepts, kinematics, net force, all that good stuff. Alright, next problem. That's, oh, one more problem to go, 62.